So check it out. You guys ready? I've got with me here two graphs, and one of the things. All right, so check this out. Here, you guys ready? I've got here with me two graphs, and this graph over here will be f of x. That's the dotted line, and over here will be g of x. What is it that you dudes can tell me, or well, dudes and dudettes, can tell me about g of x? What kind of graph is that? Chime in. Come on, throw it up there. It's a cubic graph. Yes, exactly. We know it's a cubic graph because it has two bumping points. It starts down, it ends up. So it starts in the opposite direction that it ends. Yeah, totally a cubic graph. What about the dotted line? Bop, 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 bop. What kind of graph is that? Come on, you guys, chime in. Throw it up there. This dotted line right here. You awake? A parabola, exactly. It's an x squared term. So it's a parabola. Now, this right here is a sad parabola. It's a parabola that opens down. I can tell you that the form of this parabola is probably going to look something like, it's going to have a y equals x squared. It's definitely going to have the x squared term in there. It could have an x term in there. I'm not exactly sure about this particular parabola. It looks to me that if I were to graph that parabola, or if I were to come up with the equation, it would probably be y equals x squared plus 6. Because it looks to me like it crosses up here at 6. But that's not the point of this lesson. The point of this lesson today is not be able to pull this out. But what it is it's to take a look at the graph, and sometimes we want to know, when is the dotted line graph bigger than the solid line graph? So what we want to know is, when is f of x greater than g of x? Now all you would do to do that is, if you had the graph, if you could figure out what the graph looks like, which is kind of the reason why I spent so much time teaching you guys how to translate from the equation to the graph. But if you had the graph, then what you could do is you can just say, all right, well, it looks to me like it crosses here at about positive 3. Right? At x equals positive 3. So if you're asking me, when is f of x bigger than g of x, I would say it looks to me like f of x, which is the dotted line, is above g of x anywhere in this region. So it's from this point all the way down. If I were to give you like that in interval notation, I would say x such that, actually this is an interval notation, this is set notation. All right, x such that x is smaller than positive 3. Actually, no, I'm sorry. I think that's interval notation. Set notation is this. Somewhere in between negative infinity to positive 3. Actually, you know what? I guess my question is it a solid bracket or is it a parentheses? And I would say it's a parentheses instead of a solid bracket, because what I'm saying here is f of x is bigger than g of x if you're in the region anywhere between negative infinity and 3. Does that include 3? No, because at x equals 3, f of x is equal to g of x, so f of x is not bigger than g of x. They're the same. So they can't be bigger, they're the same. Does that make sense to you? Alright, so this is the motivation behind this concept today. What we're going to do is we're going to be able to take a look at graphs and then kind of decide when one is bigger than the other, or when one smaller than another, or actually when is one equal to each other. And the best way to do that, the easiest way to go about doing that is taking a look at the graphs.